Hello everyone. Today we're going to talk about Physics 252, Week 6, problem number 26.34. In this problem, we are talking about the energy stored in capacitors and how the voltage changes, in our case, when a defibrillator is used on a person. So I chose this problem because I thought it was really interesting to talk about how these physical concepts, such as uh, whatever it may be, charge and electric potential, kind of is used throughout modern medicine to save people's lives or to make lives easier for people, whether it be defibrillators, or I believe the book gave an example of someone measuring their body fat index from the charge in their body, which I found to be very interesting as someone who's had a lot of experience in the hospital from breaking bones. So I really enjoyed this problem. It's relatively straightforward. We're pretty much just building on our ideas from chapter 25, in that we talk a lot about how energy is, or excuse me, potential energy relates to the capacitors and, in our case, power. So just starting the problem here, if we look at what we're given the capacitance of the capacitor in farads in our defibrillator, and we're given our power, and we're given a time interval. So I've gone ahead and drawn out a little image of what we have going on here. So we have our power and our time. We have our defibrillator, excuse me, and we have some kind of discharge right here. And then we have our, I just drew a simple little capacitor here to indicate that we have our 85 microfarads. So just getting into the problem here, we have two equations that we're going to be predominantly working with, one of which is the 26.25 equation, in which we are given the potential energy of a capacitor. And so for this, it looks actually extremely similar to that of the kinetic equation, kinetic energy equation. And we also have our equation for power here, which is the change in energy divided by the change in time. So what we can do is we can start off by rearranging, because our goal is to get these equations to equal each other, because then we can solve for our voltage here, our voltage of the capacitor, which is our VC right here, or the potential difference. So just getting started here, we have that the change in energy is equal to power times our change in time, and we can just go ahead and plug in, and we get 32.5 joules. Then we can set this equal to our potential energy for the capacitor, and from here we can rearrange our equation so that we're getting the potential energy in volts, and we can just plug in our variables here. Here we have our energy, here's the 1/2 from the equation, and here is our capacitance in farads, and this is actually missing parenthesis, but we end up getting 901.4 volts as our final charge of the capacitor. So thank you guys very much for watching, and I hope you found this video helpful. Have a great rest of your week.